Welcome back everybody. Hi, this is Saurav. In this video I'm going to discuss about IP subnetting and I'll show you an easy way of subnet calculation. Well, before I go to the main part, let me recap whatever we discussed in the previous video. Uh, I won't take much time. Well, these are the things that we discussed in the previous video. IP versions, IPv4, different class for IP address, subnet mask, default gateway, private and public IP addresses. We discussed different class of IPv4. As we know, we have 5 different class and A, B, C for unicast communication, D is for multicast communication, and E is reserved for experimental purposes. And as per the first, I mean, if seeing the first decimal of IP address, you can identify which class it does belong. Like if it is starting with any numbers from 1 to 126, that means it is class A. 128 to 191 means class B, and 192 to 223, this range means class C. And 127 is reserved for loopback. We have discussed and I told you regarding loopback address in the previous video. And this is the thing, network and host addresses. How will you identify how many bits are network and how many bits are host in any given IP address? If it is class A, then first 8 bits will be network address and 24 bits will be host address. And for class B it will be equal like 16 16, and class C means 24, first 24 bits are network and last 8 bits are host. And subnet mask, we can easily figure it out how many bits are network and how many bits are host using the class of the IP address. But how will you let the machine understand? This is where the subnet mask concept evolved. I mean, if it is class A IP address, then the subnet mask will be 255.0.0.0.1, as it will be written in binary form. So machine will do an bitwise AND operation and it will get to know how many bits are network and how many bits are host. So for class B, subnet mask will be 255.255.0.0, and this will be for class C. And now default gateway. What is default gateway? It means in case if you want to connect or communicate with some host or computer which is in different network, then what you need to do first, you have to go out of your network. So this is the gateway. Like if any IP address, this is your IP address, then the network part will be same as the default gateway. We have discussed this part as well in the last video. So we are moving ahead. This thing also we discussed in the previous video, like class C IP address, how many hosts we can get in any network under class C IP address. Like it is given an example of class C IP address, that is 192.168.10.100, and this is the prefix 24. It's also known as CIDR. CIDR stands for classless interdomain routing. So this defines that 24 bits are network for class C. So subnet mask will be 255.255.255.0, and this is the default gateway for this IP address. Now, how will we get the number of hosts can available in any network, given network of the IP address? So here the formula is 2 to the power 8 minus 2. This 8 came from, this will be the number of host available, number of host bits available in that IP. This is class C, so this part is host. So in binary, if we split it into, if we convert it into binary form, we'll get some 8 bits. So 8 bits are host in case of this class C IP address. So 2 to the power 8 minus 2, so 254 total host we can achieve from this same network of class C IP address. And the remaining two, one is network ID and another is broadcast ID, and in between 254 are host ID. So in case if it becomes tough for you to control these 254 hosts in under same network, so that's where the idea of subnetting came. Subnetting means nothing but dividing a huge network into small subnetworks, small and multiple subnetworks. So it's like splitting it up. Well, I can give you one simple example. Like when you're building your house, you don't make it a single room or a huge single room. We we differentiate it like one kitchen, one bedroom, like these different rooms, so that we can fulfill our work appropriately. So similarly, in case it is tough for you to control this 254 number of hosts in under same network, then we can split it up. So this is this is the here the idea of subnetting came. Well, I'm now going to the main part. Now, how will we calculate? How can you calculate subnets? There are 5 steps. These are the easiest. This is the easiest way how you can achieve a subnet, different multiple subnets from a given network. Well, you have to remember these steps. Once you start doing some problems, then you will automatically keep this in mind. There is nothing such very huge rules and all. These very simple steps. Well, let me read it out. In the next slides, I will discuss all the steps with an example. The step 1 is saying that it's saying how many subnets are required or how many subnets are possible. That depends. Like if you are given a big network and somebody is asking you to split it up into 4 subnets, then the number of subnets that you need is 4. So this is what step 1 says. Now what is step 2? That is saying that how many hosts per subnet is required. Step 3 saying that valid subnet mask after subnetting. Step 4, it states that what are the valid subnetwork IDs for each subnet. And the last step, that is step 5, it's saying that the first and last host address and the broadcast address for each subnet. Well, if it seems pretty hectic here to read those statements and these like these all rules steps, well, I'll explain the entire all 5 steps with an example, and that will be easier for you to understand, I think. Well, here is an example. This is the IP address given to you, like 192.168.10.0 and 24 prefix, like 24 bits are network. So as it is a class C IP address, it means 24 bits a network, first 24 bits. So we need to break this network into 4 small subnetworks. So what are our requirement? The first requirement, it's saying that we need 4 subnets. We have already got the answer for first step. We need 4 subnets and we need to find out the network ID and broadcast ID for those 4 subnetworks. Well, let me start with the different 5 steps. The first steps, as we already know that we need 4 subnets. So the formula says 2 to the power n, where n is the number of borrowed bits. Subnetting means nothing but borrowing host bits into network bits. So to achieve 4 subnetwork, we need to borrow 2 host bits. So 2 to the power 2 equals to 4. So here the table says initially we had 24 bits at network and 8 bits as host. Now we borrowed 2 host bits as network bits. So after that, total number of network bits become 26 and total number of remaining number of host bits become 6. Well, step 2, how many hosts per subnet? We have already got 4 different subnets. Now under each subnet, how many hosts we can have? The formula says 2 to the power n minus 2, where n is the remaining number of host bits. Here we got to know that the remaining number of host bits is 6. So here n will be 6, 2 to the power 6 minus 2. So total we can have 62 hosts per subnet. And one thing to mention, whenever we have created 4 subnets, we got 4 different network IDs and 4 different broadcast IDs. One network ID and one broadcast ID for each subnet. So as there are total 4 subnets, so total 4 network IDs and 4 broadcast IDs, and total 62 into 4, 248 hosts. We'll be discussing it in the next slides. Well, as a step 3 saying valid subnet mask after subnetting. Well, let me go back to some previous slide. I would like to show you that here in this address, initially when we didn't do any subnetting, the subnet mask was 255.255.255.0. as it was class C IP address. Now after subnetting, this thing will change, because initially for this subnet mask total 24 bit as network, but later after subnetting we borrowed 2 host bit as network bits. So the subnet mask will change, because right now after borrowing these 2 host bits we have a total of 24 plus 2, 26 number of network bits. Now the place value, we need to find the place value of these 2 bits. Well, this is how we have to find it. This is 0 1, place value for this is 1 2 3 4 5 6 and 7. So for this bit it will be 2 to the power 7, and for this bit it will be 2 to the power 6. Adding up these two we get 128 plus 64, that is 192. So valid subnet mask after subnetting will be 255.255.255.192, where the CIDR is 26. As I just said, total 26 number of network bits. Sorry. Well, the next step, that is valid subnetwork IDs for each subnet. This formula saying 2 to the power n, where n is the remaining host bits in the octet from which we borrowed. Like from this octet we borrowed host bits. So 2 bits we have already borrowed. So remaining number of 6 bits. 6 bits remain. So n will be 6 and total is 64. So to find out valid subnetwork ID, we just need to add it up 64 with the first one. Like the first valid subnet will be 192.168.10.0, because for class C this part is the network. So this is the first subnetwork ID, and add 64 with that, we'll get the second valid subnet ID. Again 64, adding up 64 with this we got 192.168.10.128. This is the third valid subnet, and the fourth one is 192. But in case if we add once again 64, then it will exceed to 54. So that is why fifth subnet is not possible here for this example. Now the last step, as the question, the example. Okay, let me show you once again the example. It asked us to find out network IDs and broadcast IDs for those 4 subnetworks. Now in the last step we can find out first and last host address and broadcast address for each subnet. We got 4 subnet. The first valid subnet was 192.168.10.0, that is the subnetwork ID, and the first host address for that first valid subnet will be 192.168.10.1. In between the entirely 1 to 2 to 3 to till 62, it will be the host address. Total 62 host, as I just told you, total 62 host available for each subnet. So total 62 host address. This is the first host address and this is the last host address for first valid subnet, for this subnet. And the broadcast ID for this subnet will be 192.168.10.63. And the second valid subnet, as I already told you here in the previous step, this will be the second subnet. So if we want to find the broadcast for this second valid subnet, we just need to minus 1 from this valid from the next subnet. Like for second subnet, if we want to get the broadcast, we need to do subtraction 1. We need to subtract 1 from the next subnet. You got the idea, right? What I'm trying to say. This is the thing. So for this second subnet, this is the subnet ID, and the next will be the first host address for second subnet. So the first host address for second valid subnet will be 192.168.10.65. From 65 to 126 will be host addresses. So the last host address for this second subnet will be 192.168.10.126, because 127 will be the broadcast ID for second subnet. So adding up 64 we got network ID. So this is the fourth valid subnet, and first host address for fourth valid subnet will be 192.168.10.1 to 93, and the broadcast address for the fourth subnet will be 192.168.10.255. This is how we can achieve the valid subnetwork ID, host address, first host address, last host address, and the broadcast address of each subnet. Well, I think it was pretty understandable for you to get the idea how can we calculate subnetworks from a big network. Well, a question may arise that is it possible to create three subnetworks and that too unequal distribution of hosts? Yeah, because as we have seen that the formula in the first step, the 2 to the power n, when if we borrow one bit from host bits, then we will have total 2 to the power 1. That means two number of subnets. If we borrow 2 bits, then we will have 4 subnets. If we borrow 3 bits, we will have 2 to the power 3, that is 8 subnets. So now, is it possible to get 3 subnetworks or 5 subnetworks? Yes, that is also possible, and that too unequal distribution also possible, because in this example I have shown you equal number of distributions, 62, 62, 62, 62. But yeah, that is also possible for getting unequal number of hosts. So I'm giving you one example. Like, for example, in an engineering college, let's assume that in computer science department they have total 120 students, and they need 120 computers, and for electrical department they have 60 students, so they need 60 computers, and EIE, that is electronics and instrumentation department, they have total 50 students. That means they require 50 computers. Well, in case if you're wondering why did I pick this EIE department instead of so many mainstream branch of engineering, is because I completed my BTech from EIE branch. Well, jokes apart, let me focus on the main question. So in case if we want this unequal number of hosts, so we can achieve it, and for that part, first we will borrow one host bit as network bit. So after borrowing one bit, we can divide it into 128 and 128 total into, we can divide this entire network into 128 and 128. And for this subnetwork, first one will be network ID, 126 number of host ID, and one broadcast ID. So 128 gone, and remaining this 128 we can split it up into two equal subnetworks, 62, 62, by borrowing the second host bits. So here we can easily achieve this unequal number of and 3 subnetworks. Like we can easily assign 120 computers under this subnetwork, and 60 computers under these subnetworks, and 50 computers under this subnetwork. So I guess this video helps you to understand the idea of subnetting and how can we calculate subnets. Well, in case if you're having any questions, any doubt, you can comment in the below comment sections. I'll try to solve your query. And if you like this video, please subscribe our channel. Thank you. Thanks for watching. Have a good day.